present the slides. Good. So be presenting this conversation today around defensible architecture for APIs. We'll touch on a couple things. My background, I work for Albertsons today as the principal architect for cybersecurity. A lot of the day-to-day, because it's such a large environment with so many diverse technologies and capabilities across the spectrum, a lot of it is API driven. So one of the big things today, I really want to make sure I put this out there up front, omissions and errors, insurance requirements and all that. I'm not a lawyer. This isn't legal advice. This content might not discuss your needs. The hack back, strike back stuff, when we talk about active defense, cyber deception, that's not on the table. That's not what we're talking about today. And note tripwires versus poison and venoms. Tripwires are passive stuff. We set up the string, somebody trips on it, and maybe we detect it, but the goal is to be able to detect it. Poison is, they're going to get something, and because they took an action, it's impacting them. Their own action is impacting them. Venom, on the other hand, is if we're reaching out and doing something to them. That's really where we want to differentiate. It's the hack back, strike back stuff, not on the table. Talk to your corporate counsel about that stuff. HR 3270 pending. Make sure to look into the regulations if you're interested in those things. But that's not what we're talking about when we say active defense today. So a kind of common misunderstanding: architecture is not complex diagrams, right? That's maybe a big misunderstanding that I've come across a lot. I still see day to day. What we see on the screen is kind of representative, unfortunately, of how a lot of enterprise architects may work, how a lot of solution architects kind of think their work product should be presented. Reason is that we're talking about a total system, right? And it's all of the systems, that the people, the process and technology that need to interact, that need to work for stuff. So when we talk about defensible architecture, it's got to work for the total system, right? Not just your team, not just by architects for architects. The engineers have to understand, the developers have to understand. The defensible architecture is one that actually works, that can actually be adopted, not just one that looks good on paper. If you've read through the DoD's Zero Trust Reference Architecture or NIST's Zero Trust Reference Architecture, great documents, a lot of good information there. Not super accessible to most folks. So it's really critical. The other aspects is your processes are going to be different. So we can talk about different architectures, but at the end of the day, the one that works for your team is what matters. And it is best if it complements your technology. And so that's what do you have in place. There is a reality of, this is our target state that we want to strive for. And on the other hand, this is what we can accomplish today. This is what's feasible today. So when we look at patterns, and this is one of the bigger areas where I see some kind of gaps, some issues with a lot of organizations. Straightforward diagrams, as you notice, like I'm not in the diagrams that are on the screen, they're not presenting super complex stuff. They're easy to follow, basic shapes for the most part. We're not looking at rack elevation diagrams at the same time as logical connectivity diagrams. Right, so all of this stuff, it plays together to create an understanding of how the total system works. And the key to that is that your engineers should be able to take that and run with it. They should be able to see what needs to be done to implement a pattern. So your architecture patterns are your building blocks for your systems, and then you build your total system, your solution architecture off of those patterns, tuned to the specific use case. But if the patterns aren't actionable, if they're not accessible, right, then they're not actually going to be used properly. That's where, if you notice in these diagrams as components of a bigger pattern, that they would also include the black and white one on the right hand side, for example, shows the Istio config to make sure that you're actually validating tokens and calling back to the identity provider for an OAuth 2.0 flow. So those JOTs aren't just, as a previous talk had mentioned, those JOTs aren't just decoded, they're actually validated. So again, like the best architecture is the one your team understands and uses. It's not defensible if, as great an architecture as it could be, if it's not actually implemented according to the way it was intended. And so this touches on a little bit of that kind of audit concept of, the design of the control versus the operating effectiveness of the control. Those aspects become really, really critical in how we actually incorporate improvements into our environment that make our total systems more defensible. And so some of the most key things that we can do right off the bat is just prevent basic unforced errors. Right. So the hardest things to get right in any environment, especially exposed to the internet, are authentication authorization and encryption and tokenization. These are things that are heavily reliant on very complex math, and there's just not that many people that are so good at math that they could roll their own auth or their own encryption. So again, like for both of these, there's open standards. Getting it right is really hard, and if you don't get it right, it goes really bad really fast. So the key here, we've got token-based auth, so your OAuth 2.0 OIDC, especially where you're performing that redirect, that client-initiated backend authentication, that's critical to get authentication right for modern APIs, modern web apps. And if you were using, for service principal based authentication, service to service API calls, key and secret authentication with HMAC, not by itself, right? Is feasible. There are options with workload identity federation, with especially if you're looking at Azure at Enter ID, your system generated managed identities. Those service principals, you're not even handling credentials, right? So there's a much higher order or a much higher level of assurance that can be provided that way. And then certificate-based auth, which, again, MTLS provides the encryption and the authenticity because the client certificate makes sure that you know who you're talking to, even from the server side. So, and then of course MTLS everywhere, TLS if MTLS isn't realistic. For those of us, running our APIs in heavily containerized environments, Spiffy is the perfect example of leveraging MTLS throughout the entire infrastructure, right? So go and look at how your Istio, or if you're in GKE, your Anthos config, make sure that you are actually issuing those X509 certificates to your pods. That is how you actually get MTLS set up between your containers, between your apps. So again, like good hygiene is foundational. And we say this because, at the end of the day, I'm sure we've all heard this a dozen times, it's also the easiest thing to not get right. Countless organizations that I've worked with, that I've supported, have really done the lift and shift into cloud. And the issue with that is that your cloud environments are not designed to operate like a data center. You don't need to run your own internal privately routed network. GKE, or excuse me, Google Cloud, for example, has Aurora as their software-defined network underlay. Leverage that, right? If you're scanning, for example, you're running a container that connects to a Google API, you're not connecting over the public internet, you're connecting over Google's underlay, their Aurora software-defined network. That means you don't have to implement all of the same things at the same level as you would in a data center. But in order to leverage that properly, you have to look at it as a cloud native environment. And this is where hygiene starts to slip for a lot of organizations, either because they expect that it's something that has to be configured rather than a policy that should be applied to an entire project, an entire subscription, if we're talking Azure, or to the entire environment overall, your entire tenant, your entire account. But instead, a lot of what we end up seeing is that the expectation is that, I'm still going to use Ansible because I'm still going to use virtual machines, and I still need to set up my firewalls with very specific policies. And these are all opportunities for human error to enter the equation. These are all opportunities to miss a connection that ultimately needs to be filtered or blocked. And these are all opportunities for an application to ultimately make a connection outbound or accept a connection inbound that it shouldn't accept. Whereas when we implement the policy around our entire infrastructure, those landing zone policies, not administrative policies, the technical policies you configure through your cloud provider, those policies reinforce the intent of all of your controls. It's translating your controls to the technical configurations and not allowing human error to prevent those from actually working. And so what we see on the screen is, again, I love simple, straightforward diagrams, right? Keep it basic and straightforward, and spend your time on getting it right, not on making it look perfect. Um, these are core items, right? And good hygiene is foundational in the same sense that you cannot build uh, multiple floors if your foundation isn't stable, right? Eventually, what you end up with is your whole house collapsing or shifting because you've been building on top of an unstable foundation. It may not collapse all the way. Instead, what you see is this constant need to continually fix all the little things that are breaking, and that's technical debt rising up, right? So a lot of mixed metaphors here, but the core of it here is good hygiene is a foundational component to a defensible architecture, to making sure your APIs can be defended. So the other aspect, a lot of our understanding, if we go back to the version 1.1 of the NIST CSF, when we talked about the 5 security functions, the CSF 2.0 added some, added govern, right? But when we think about the identify, protect, detect, respond, recover model, right, it doesn't really look at the motivations behind an attacker the way that we would hope, right? And so understanding why attackers target our environments, understanding why they do what they do, right? They're investing resources because they expect a return on their investment. So disrupting their return on investment should be our goal, right? We want to make it expensive for them to target us. They're going to target us, right? That's the reality. Go and put anything online and watch how quickly it starts getting scanned, right? As soon as you open up port 22, it doesn't matter where, it doesn't matter what your IP is, it doesn't matter if you're actually, opening port 22 to, SSH on the back end, it's going to get scanned, right? In probably within an hour. So for us to understand how to disrupt attacker ROI, we first have to do the preparation to understand our environment and understand how it will be targeted. And what we're trying to accomplish with this is to increase what the attacker has to do, make it more expensive for them, and decrease what we have to do to serve them more expensive content, right? To make it more expensive. And I like the example of, as we observe likely suspicious or unauthorized traffic inbound, we redirect that instead of just block it, right? As soon as you block it, you're telling a bot actor, you're telling an attacker, hey, I've detected you. Now you need to change your behavior to stop being detected, right? It's not a natural evolution. It is strategic. There's another person on the other end of that that's intentionally making decisions. So every time you block, every time you give them an indication that they've been detected, you're telling them, go ahead and adapt now. I'm ready for you to do the next phase of this game. Whereas redirection and serving them expensive content, right? So if you're talking about an API request to a publicly accessible API, one of the biggest impacts to it is unlimited resource consumption, right? Bot attack hitting an API and your dynamically scalable environment, your compute costs are going to skyrocket, right? If you have a component that's redirecting to a third-party service and you're paying per request or per 1,000 requests, your costs are going to skyrocket as those bots continue to target your API. This is Cloudflare's model, right? You pay for the volume of requests that go through their infrastructure. Google's the same way for their retail APIs, right? So when you're looking at that, the response isn't to let it flow all the way through your environment, to block it at the app. But if you're blocking even at the very front end where it would cost you the least to process any of the traffic, let's say you pick it up at your web app firewall at the very perimeter, you're just telling them that they need to change so that their fingerprint doesn't get caught by your WAF, right? If it's a pure rate limit and you're not looking at any headers, you're not looking at any signatures, you're still telling them that they need to adapt their pattern of behavior. If you're redirecting and you're sending them responses that are intentionally slow, that are uncompressed, right? A large volume. And if you're sending it from a cache location with meaningless data or with data that is misleading, right? Then you're creating a condition where they're processing it very slowly, they're processing it at a higher volume because it's being sent uncompressed, right? These are all things that increase the cost, but it's not being sent all the way through your infrastructure, right? So to do these things though, you need to be able to integrate across your stack, right? So that is from end to end, view your total system. What are the things that need to happen? And I love looking back at a CrowdSec, right? So CrowdSec, if you're not aware, stick a bouncer on your endpoint on your web server, and it's checking which APIs are coming, or excuse me, which requests are coming in. It's checking the source IP, it's checking information about it, looking for indicators of compromise, and or excuse me, indicators of malicious activity to bounce that traffic off. But it's not just looking for it based on what CrowdSec sees from your environment. It's connecting with everybody else that's running CrowdSec. Right, so you get that crowd environment. That's integration across multiple apps to be able to provide that, right? That visibility. So a lot of this comes around how do we integrate it across it? We have to start with the right question, right? So we ask the right questions around access control, right? So when we break this down, and I have a much bigger version of this, because you start asking questions, what are the traits, the aspects of each of these components, right? It's not just can John do the thing? It's can John do the thing on that particular object, on that file, on that application, on that machine? But it's not just can I do it, because my identity is also dependent on how I'm authenticated, right? It's also dependent on what attributes are displayed about me and my current session, right? Where am I authenticated from? What device am I on, right? What is the security posture of that device? When we think about in the Microsoft realm, your Entra ID, tier 0 admins, your global groups, right? What are the best practices for those, for members of those groups? It's looking at conditional access, right? Can admin A perform an action? We want them to be authenticated with the right account, the right way, from the right location, but we also don't want them to be doing it through just any PowerShell script, right? We want them to be doing it through a PowerShell script that we approve, or directly through the console, right? And should he be able to do it against an aspect of our environment that is relevant in a different way, right? So maybe that admin is not supposed to work in a specific subscription or one of our related tenants. We need to make sure that they have the right ownership, the right attributes to perform that action against that particular object as well. This all requires a lot of preparation. And a key part of that is understanding how these access control models complement each other. So when we talk about role-based access controls, attribute-based access controls, and relationship-based access controls, right? These things all complement each other, but you're not reading off of Active Directory all the time. When we're talking about API architectures, very often our policy enforcement point, our policy decision point, right? Throwing out some kind of zero trust terminology. The key is that it's in line, it's in flight, and that we're making decisions based off of our implied authentication or our validated authentication, right? If we're doing, for example, a lot of your single page applications, the API requests, there's stateless. There's no session management directly within the back end. You're looking at the token that's sent in the auth header every time, every request, or at the very least for all of your sensitive requests, right? And when we're doing that, we're performing this check every time. So we can't wait for a totally distinct and separate authentication point to give us, or excuse me, authorization decision model authorization point to give us the response. It needs to happen much more co-located with the actual application. Hence, a lot of apps are not relying on the token being checked every time it goes back, because we have performance concerns in a retail environment. Like, that is impacting your performance budget. So you want to tie it up the right way by understanding how these models fit together. you can say, okay, coming in, I know that my JOT has these claims, this scope, and that the user belongs to a group that permits that, right? And as you filter down through your permission structure, you're looking at row level security, you're looking at your functional access model, what functions can actually be called, right? These are things that matter to make sure that you're actually structuring your access model in a way that doesn't permit mass assignment flaws, that doesn't permit broken object level or broken object property level um, access, right? Those errors come up because we don't effectively apply access control models. The biggest thing that I have observed in my limited experience is that technical debt is what stops us from progressing and advancing these areas. When we recognize a weakness, very often organizations are quick to acknowledge, yep, that's a weakness, and then everybody nods their heads and says, okay, now we're going to go back to making money. And the big difference here is that for most organizations, infosec isn't a revenue driver, right? Information security is a cost center. So how do we justify spending more money when the goal is to reduce the cost? This is where we have to understand what technical debt is. And the reason it's termed as technical debt is because debt accrues interest, right? And it is when we're talking about APIs, we're talking about things that spread vast. I think there's a talk on API sprawl and how to manage that. If you don't develop a strong inventory of APIs and an inventory that includes all the necessary information, right? We're talking about a situation where there's actively a lot of interest accruing, and it takes a lot to pay it down, right? So it will get more difficult. You will have more difficult incidents. You'll have more complex incidents. It will be harder to pay it down over time. You have to go and do that. One of the core aspects, we talk about design for malice. In this flow, we see that there's an active connection from a valid web browser. We see the flow all the way through where we hit an authenticated API, right? So at 7, we're hitting that authenticated API. After the service mesh, if you see from 5 goes from the app gateway or proxy to the service mesh, and then 6 checks back, step 6 checks back with the identity provider, right? And based on that, we're routed to the authenticated app. But we see a threat actor that's targeting it, and we're redirecting them from the service mesh, right, to the X API that is not authenticated, so our unauthenticated app. And the point behind that is that when we look at these two functionalities, we're separating the use cases, right? Maybe we want to serve it, but we still want to serve that traffic, right? And we can split that, but don't mix up your apps and don't mix up your apps across different security domains, right? Your authenticated traffic, don't have that flow to the same place as your unauthenticated traffic. It's split that up. I noted also in the edge layer, there's a separate box for partner there. Your partner APIs, your partner connections for your APIs, they're likely going to have much more consistent and straightforward calls and a much higher volume of calls. That's a different rate limiting requirement. That's a different pattern. Don't point those to the same URL, even if they end up going to the same backend API, the same code, the same containers. Point them to different front-end URLs so that your WAF can actually protect those endpoints according to the needs of that use case. We're moving quickly here at the end here. So again, like we're talking about architecting for the total system, right? The end-to-end system. What does unauthorized access look like? What will data leakage look like? How will you detect that? How do you confirm that, right? What does normal traffic look like? What's my baseline? How do I establish my rate limits, right? So I know what to expect. What should throttling look like if I detect unusual activity, right? What is the developer experience to correct a vulnerability? And this is maybe an often overlooked aspect of a good defensible architecture. It's possible for developers to fix the vulnerabilities, not just know that there's a vulnerability, but know where it is, know what the recommendation is, know what the impact is so that their leaders can prioritize their backlog. How do we assure, and this is key, right? How do we assure that the value that the A provides to the organization, but it's not there for nothing. We're not just there to make sure that nothing goes wrong with it. We're there to make sure that nothing negatively impacts the value that API provides. right? So we focus on right sizing our approach. That's the active defense concept, right? It's not a checklist of controls. It's risk oriented. It's threat informed, right? So what that tells us or helps us understand what attack techniques we need to prioritize defending against. And then finally, and maybe the most critical thing that should underlie all of our technical careers, how do we avoid reinforcing technical debt? How do we pay down technical debt? How do we avoid getting locked into those issues? And finally, when we talk about active defense, at the end of the day, we're talking about attempting to trap the attacker in the pit of our success, right? So we mentioned before, disrupting attacker return on investment requires prep. That prep means hardening. That means good vulnerability management. If we are not if we're not handling our vulnerabilities well, our attack surface has porous opportunities for attackers to gain a foothold, whereas we can present false opportunities for attackers that help them land in the pit of our success and slip into it. As we compress our attack surface, our surfaces, our angle goes up, and it's much harder for attackers to gain that foothold. So I did list several additional resources here. I love at the bottom those GitHub repos. Check those out. These are excellent resources across the board. I think there's an author here that may have introduced me, but all of these resources are valuable, are helpful. I can't say enough. If you start anywhere, start with The Active Defender by Catherine Ullman. Excellent book. It'll point you in so many directions, and just be interested. That's 25 minutes. What questions can I answer? I'm looking through the comments here. Are there any that stand out? Maybe Corey, to you.
John, thanks so much. Yeah, great talk. Let's see. Anyone have any questions for John? We do have a few comments. Alicia, I like running prevention active defense models. How do you feel about this? We tell our internal leaders security is a table stake that can end business, and we are insurance against bad days.
Yeah, I mean, there's an argument for that, and I put it as I like the way Albertson CISO has phrased it, that infosec in retail is a cost avoidance mechanism, right? It's there to avoid unnecessary costs, right? And it helps keep the focus on the right areas. We can talk about being an insurance against bad days, and that's accurate, right? That's relevant. We don't pay more for insurance than the value of what we're insuring, right? At its core. So it works in both directions. We talk about risk in InfoSec, and we often miss the point. Businesses make money by accepting or by taking on risk and then doing the work with resources that generate more revenue than what it costs to mitigate the risk. So if we're looking at it from that same perspective, which again, like I agree with what you're saying, if we look at it from that perspective, we want to show that we did the work for a high risk to bring it down low, and that the work that we did cost less than the actual likely realization of the risk. From a, not to go too crazy, right, risk quantification perspective, how much would that attack cost? How likely is it that you would be targeted on an annual basis? And what are the controls that reduce the likelihood and impact? If you can quantify that and show that you're spending a lot less on the tools than what the difference is in the cost of risk, you're showing a positive return on investment. It's